Hi everyone, and welcome to day 7 of Advent of Code. Today we'll be doing some live coding, so I haven't looked at day 7 yet. Well, once again, I did look at the leaderboard, and it looks like this one took a significant amount of time, even for the top 100. So hopefully we can get through it without needing to look at any hints. But either way, let's just get right into it. Day 7, camel cards. Your all expenses paid trip turns out to be a one-way, 5-minute ride in an airship. At least it's a cool airship. It drops you off at the edge of a vast desert and descends back to Island Island. Did you bring the parts? You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. Did you bring the parts? She asks again, louder this time. You aren't sure what parts she's looking for. You're here to figure out why the sand stopped. The parts. For the sand, yes. Come with me. I will show you. She beckons you onto the camel. After riding a bit across the sands of Desert Island, you can see what look like very large rocks covering half of the horizon. Elf explains that the rocks are all along the part of the desert island that is directly above Island Island, making it hard to even get there. Normally, they use big machines to move the rocks and filter the sand, but the machines have broken down because the desert island recently stopped receiving the parts they need to fix the machines. You've already assumed it'll be your job to figure out why the part stops. When she asks you if you can help, you agree automatically. Because the journey will take a few days, she offers to teach you the game of camel cards. Camel cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. In camel cards, you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled one of the 13 cards. The relative strength of each card follows this order, where ace is the highest and 2 is the lowest. Every hand is exactly one type. From strongest to weakest, they are 5 of a kind, 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair, high card. Cool. Hands are primarily ordered based on type. And then okay, so if 2 hands have the same type, so for example, 2 full houses, the first card in each hand. Okay, interesting. Yeah, so the tiebreaker isn't like the odd one out, but the first. So it gives an example. To play camel cards, you can put a list of hands and their corresponding bid, your puzzle input. This example shows 5 hands, each hand followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank. Where the weakest hand gets rank 1, the second weakest hand gets rank 2, and so on. Okay, so it's the rank within these 5. Okay. So yeah, basically we need to rank these 5 hands and then multiply by the bid amounts. Yeah, okay. Let's take a look at the input. Yeah, so obviously you have a lot of hands in the full input. Let's just get into it. Let's copy over our example. Looks right. And then the full. Looks right as well. All right. Let's set up our watch script. Okay, so I think the first thing we want to do is simply parse the hands and the values before we get to actually solving the problem. Yeah. So I think we have hands and then bids. Iterate over the lines. Hand equals So we have hand and bid. We can just split on that space. And then I think we'll also want to set up like a card values dictionary, which is a mapping from the card, which is like a single character, to the value. So ace. Yeah, because we need like, we'll need some notion of like the ordering of the cards, which obviously doesn't work for strings. So yeah, there's probably a faster way to do this, but here it's just if anyone knows a fast way. I know there's some way like to highlight all these, at least from 2 to 10, and use some kind of like find and replace, but I don't know how to do that. If anyone knows, let me know. 10, jack, queen, king, ace. And now I think what we can do is we want to replace all right, whatever, let's just do this by hand. Yeah. Oh, I'm stupid. Okay, cool. There we have our card values. So now I think we want hands dot append yeah, so that's just going to give us a list of the card values as numbers. And then we just cast the bid to an integer. All right, cool. Let's print print out what we got. And let's maybe check. So we got 3, 2, 10, 3, 2, 10, 3 king. That looks right. And then 765. Okay, yeah, that looks right. So now we have to actually solve the problem, which involves sorting these. So it really doesn't seem that hard. I think we want a function to compare two hands and return which one is higher. Then can you call, like, does Python have like a way to sort a list using like a custom comparison function? Let's look at that. Because I don't really want to write my own sorting algorithm. Yeah, I guess they have this way to do the key. Okay. So I think what we can do is write a function and to score that takes in a hand which is a list of integers, returns a score, which is also an integer. And what we want this function to do is map each hand to a score such that better hands have higher scores. And now yeah, okay, so implementing this is going to be the main thing. Let's just finish up this part one function, treating hand to score as like a black box. So maybe, since we're going to be sorting the hands, we're going to be calling hands.sort. And then key is hand to score. And then instead of bids being a list, let's have it be a dictionary where we look up using the hand. Or we can create like this. I think that would maybe also work, but we can create like hand bid pairs, which looks like this, and then we can sort hand bid pairs. Let's I think we might have to do this. Yeah, cool. And then we sort these pairs, and then we want to map the pair to the score of the hand, which is the first element in the pair. Cool. And then yeah, now we just want to iterate through this sorted list. What I'm grabbing out here is like the index and the bid amount. Yeah. The weakest hand gets rank 1. Okay. So then just increment the total, or increase the total by the rank, which is I plus 1, and then multiply that by the bid, and then we can return the total. Cool. So now we just have to implement this hand to score function, which is sort of the key part. So I think what we're going to want to do is, yeah. So the score should have two parts. The first being so we need all 5 of a kinds to be greater than all 4 of a kinds to be greater than all full house. So we need a way of like detecting if something is each one of these. Yeah. Okay. I think, yeah, that'll be the first thing. So so the hand type will be an enum. We need to import enums. where we have high card is the lowest, then one pair, then two pair, and three of a kind, and full house, then four of a kind, and like five of a kind. And then let's just move this up. Okay, cool. So get hand type will then return a hand type. And then I think, yeah, we should change the this should just look like that. Okay, cool. So let's implement this get yeah, and then so essentially we'll have the hand type and then the tiebreaker. Where the tiebreaker is like the ranking within each hand. So the tiebreaker is equal to, tiebreaker is pretty simple. I think that all we want to do is so right now this is maps each hand to a tiebreaker between 0 and whatever this is. I guess just yeah. And 10 to the 10. Yeah, so just like let's so the tiebreaker, yeah, just recall with the hand too. And then let's print out these three values. It's the hand, type, the tiebreaker, and then the score is just going to be the hand type plus the tiebreaker over the tiebreaker max value, I think. We can probably clean this up, but so this is going to be the max value for the tiebreaker. Yeah, so essentially now this score okay, I thought we could just like use the numerical value for the enum, but I guess we need to make an. Okay, this is starting to seem a little bit messy. Because now we have a type values dictionary, which is mapping each enum value to a number. So I'm not sure if this is really the best way to do this, but this is what we got. These two data structures seem a little bit redundant. What's this mat about? Oh, it's because, sorry, this needs to be a, geez. Okay, now we have the hand type values. Yeah. We could just get rid of these two things and maybe, so yeah, first of all, we're returning a float, not an int now. And then these are integers too. So yeah, maybe instead of having hand type return a hand type, it just returns an integer. That no, I still like how we have this before. Let's keep this with the hand type, even though it gets a little messy where we start out these semi-redundant dictionaries. Yeah, let's keep it that way for now. So now we just need to implement. Okay, so we can see that like this number is mapped to like the first. So for example, this is going to be greater than this because the 10 is greater than, you can see this is 1 digit longer, like 0.3. So this is going to have like a higher tiebreaker. Yeah, the one thing I'm potentially worried about is, are we going to run into issues with floating point precision since we're getting like quite small. But yeah, maybe we can just keep these all as integers. So max tiebreaker can return, or here when we calculate the score, instead of dividing by, we can multiply this by the max tiebreaker, which keeps everything as an integer. Yeah. So right now we're always getting the high card. Okay, so now I think we just need to implement hand type, and then this will work. Okay. So I think that we can sort of just check like if it's a 5 card hand, if it's not like a 5 card hand, but also has like a 4 of a kind. Yeah, let's just implement this. It might be a little messy. So just iterating over the cards. Actually, maybe what we can do is make like a hand set. And then if the length of the hand set is 1, and we know we have a 5 of a kind. So if it's 2, we have either a full house, or here, maybe instead of this, we're gonna do hand counts, which counts like the amount of cards for each in the hand. And then let's just verify this. So here we have 2 3s, 1 2, 1 10, and 1 13. So that's right. So yeah, if we only have 1 key, then it's a 5 of a kind. If we have 2 keys, it's either a 4 of a kind or a full house. Yeah. So I think that this will return like one of the values. I'm actually curious about something. I'm just like learning about like this next iterator syntax. So we create a dictionary that's like 1 to 2, 3 to 4. What do we call? Is this? Okay, dict.values object is not an iterator. So we have to do this. So if value is equal to 1 or 4, then we know that we have a 4 of a kind. is we have a full house. Now we can check for 3 of a kind. So if we have a count equal to 3, then we have a 3 of a kind. And then we can run this a second time. And if we have a count equal to... No, now we can do... yeah, so instead of this, we can do if the length of the hand counts is equal to 3, because we know it will be equal to 3 if it's 3 of a kind, because it's like 2 of one card and then 1 of the other 2 cards. And then I guess we can do this sort of chain conditional. I feel like we prefer this to just be like an if statements as we return in each one, right? I guess that's sort of style, but and then if it's equal to 4, that means we have a pair. Call it 1 pair. Okay, that seems pretty clean. Yeah, I guess let's just see if that works, right? Okay, 4602. Okay, so that's wrong. Okay, so let's maybe... What is like the ordering of these scores? So the lowest is going to be... Let's go, the highest is going to be this one. So this is not a 3 of a kind. 2 pair, I forgot about 2 pair. Okay. So the length of this is 3. It could be either a 2 pair or a 3 of a kind. So I think, let's look at this value again. And then for no, let's iterate over the values. Sorry, the counts. This should be count 2. Or count in hand values. If count is equal to 2, then we have a 2 pair. And then if count is equal to 3, then we know we have a 3 of a kind. $6,440. Okay, that looks like it's right. Yeah. Okay, I think let's just run this on the full solution, the full input. Okay, we have a lot of print statements which you can remove. This is our solution. Just right, nice. Okay, now to make things a little more interesting, the alpha introduces one additional rule. Now, J cards are for jokers. Wild cards that act like whatever would make the strongest type possible are now the weakest individual cards. For breaking ties, it's treated as a J, but okay, this seems complicated. But I think we have decent infrastructure built up. For part 2. All right, so let's first get rid of all these print statements. I think now yeah, let's just get to work on part 2, I guess. So we'll still want to parse the hands and the bids. And I think now how do we want to do this? Because we're going to need to deal with the jokers. So first we're going to have to parse the jokers, which I'm maybe less concerned about. So let's think through how the joker is going to be assigned. I think that the joker is going to be assigned to whatever has like the most. So for example, if yeah, so here like there's the most is a 5, so the joker will be equal to 5. For here, like if this was a joker, it wouldn't matter if it was assigned to a king or 7. Since the tiebreaker isn't like kings full 7s is not better than 7s full kings, it just matters the order. And this joker is always 1, or just the lowest. So, and then here, like the joker would just be assigned to this. Yeah, okay. So I think all that we're gonna need to do is here we want to parse now we want this sort of card values part 2. Where instead we're going to have, let's just make it explicit. So now we have card values 2, but the joker is instead worth 1. Actually, I think let's maybe refactor part 1 a little bit. So I guess we can turn the watch back on. I think that we don't here, I maybe don't want to parse the hands as we do. Maybe instead hands should be, we can keep hands as just a string. And then we can do this wherever we need to. So what we're going to need to change is in, so hand is now a string. I think this is just going to make things easier so we can reuse these functions in part 1 and 2. And get hand tiebreaker. So we have now we need to create values here. Card values, card for card and yeah. Cool. So that's the tiebreaker, and then yeah, this should work fine too. What's going on here? Okay, yeah. Okay, so this is getting the same value. I think now for hand type, we can add this additional argument for whether or not we're using the joker, and same for get hand tiebreaker. And then so in here in part 1 we'll be setting those to 0, but here in part 2, whenever we call hand to score, we want to do true. Yeah. So here when we're calling the type, we need to have the use joker. And that, yeah, so now we just need to implement this. So first for the tiebreaker, it should be pretty straightforward. The value, let's just use a for loop instead of the list comprehension, just because we have to do a little bit more logic. Card in hand, if use joker and card equals joker, otherwise okay, so I think now that tiebreaker should be fine. Let's move these up to the top. A lot of this bullshit, but whatever. Yeah. So that should be use Joker there. Now here, we'll create hand counts either way, but we'll do it differently whether or not we have use Joker on. So if we're using the Joker, first we should skip a card in hand if card is equal to Joker. Continue. So this gets the hand counts without the Joker. And then we want to get the card with the max count. And then let's count the Jokers. Max card, whatever. Just set it to default value to avoid, like, it's gonna yell at me if I don't give it value. If count greater than max count equals count, max card equals card, and then we should add for the Jokers. So hand counts max card plus equals and Jokers. Joker count. So I think this should work now. Once we fix all the random errors, this needs to be .items. 5905. Okay, let's run on the full input. So we can have a hand of all Jokers. That's, I think, what's returning here, because we have we're trying to index into hand counts with the default value. So I think that here we can just have a separate statement if Joker count equals 5, hand counts ace equals 5, and then you can yeah. Cool. So that was day 7 completed. Let's just go through our solution and talk through it. So basically, I use the exact same code for parts 1 and 2, just setting this is Joker flag to true in this hand to score function. So what I do first is parse out the hands and the bids. Initially, I had the hands parsed as numbers, but instead just left them as strings, and then when we actually need to turn them into numbers, we can. Then create this list of pairs of tuples of hands and bids, and then we sort that using this hand to score function on the hand. That's sort of the main part. After that, we just sum up the rank times the bid amount for each one of these hands. So then in the hand to score function, essentially we separate the score into two things, the type and the tiebreaker. The type is like is one of these options. And then where like this has a value of 7, 6, 5, 4, 3, 2, 1. And then the tiebreaker is within each one of these, like the score to rank between like different, say like 2 pairs or different full houses. So the tiebreaker has like a much larger value, so this can go up to like, because we're using like 2 digits for each one of the cards, get hand tiebreaker can go up to like 10 to the 10. I mean, not actually quite that high, but close to that. And then get hand type is just like 1 to 7, but we want like this to have precedence over this. So we get like the max tiebreaker, which is the tiebreaker for the best possible hand, and then multiply our type values, our hand type value by that max tiebreaker, to make sure that when we're sorting, it's first by type and then within each type by tiebreaker. And then, yeah, for get hand type, essentially we just create this hand counts dictionary, where we do that a little bit differently, whether or not there's a joker. If there's not a joker, we just create it very simply with the count of each card. If there is a joker, we set the joker equal to whatever is like the maximum number of cards in the hand, not including the joker, because that will give us like the highest value hand. Then we can just sort of go through this logic quickly. Like if there's only 1 type of card, then it must be a 5 of a kind. If there's 2 type of cards, it can either be a 4 of a kind or a full house. If there's 3 types of cards, it can either be a 2 pair or a 3 of a kind. And then there's 4 types of cards, it has to be a 1 pair. Otherwise, that means there are 5 types of cards, and so it has to be the hand type is high card. Then for the tiebreaker, we just need to use a little bit of handling for the joker, because the tiebreaker for the joker is low. It's not 11, it's 1. And then we simply use like 2 digits for each one of the cards in the hand. Yeah, so I think that does it for my solution. One thing I'm still a little unsure about is it's just a little messy having this enum, card values, type values. It's a lot of these hand type and type values seem a little redundant. If someone's got a better solution to that, let me know. The reason why I did it like this is just to keep my functions as straightforward as possible. So like hand type just returns the hand type. We could have hand type return like a score, but it just seems like a little bit more messy. Although maybe not. Maybe here, like, we could return like 5 score, for example. But this is how I have it. I'm not going to change it for now. And then, yeah. Thanks for watching. Let me know in the comments if that was helpful, or if you've got any questions or comments. I'll try and keep doing this through the whole advent of code. We'll see how long I actually make it. These are obviously taking longer than the ones at the very start of the challenge, but it's still been pretty enjoyable to do it for me. So yeah, that does it. Thanks again for watching. Bye.